measurement for current. Then number 4, define resistance, right? So I'm going to give you a quick 5 minutes to complete this activity. And please don't forget our WhatsApp number, right? If you want to send in your answers, comments, or any questions related to this topic, please, our WhatsApp number is 079 578 2908. Now let's meet again after 5 minutes. Welcome back, grade 9s. I hope you enjoyed your baseline assessment, right? Remember, our WhatsApp line is 079 right? Send in those answers, comments, or any questions regarding this lesson. So let's look at the solutions now. Number 1, what are resistors used for, right? So resistors are simply used to control the flow of current, right? They are used to control the flow of current in order to provide useful energy transfer. Altogether, remember we covered this in our previous topic, right? Then number 2, state what happens to the current in a series circuit when we add more resistors, right? So when we add more resistance, the current will decrease, right? The current decreases. Number 3, what is the unit of measurement for current, right? Current is measured in amperes, right? Having the symbol A. Then define resistance, right? So resistance is simply a force that opposes the flow of current in a circuit, right? So that's all for our baseline assessment. And yet again, I'm going to give you a quick minute to copy down the corrections. Then after that, we shall continue together with our lesson. Welcome back again, grade 9s. Now let's continue together with our lesson, right? But before we proceed further, we need to understand and know some of the terminology that you're going to come across during this lesson, right? So let's go through this terminology. The first term that we have there is series circuit, right? So a series circuit is an electric circuit that has only one pathway for current to flow, right? It is what? It is only having one pathway for current to pass through, right? It follows one pathway for current to move through, right? Then we have current. And current is the flow of electricity or flow of charge through a conductor in a circuit, right? It is the flow of electricity or flow of charge through a conductor. That is what current is. Then we have ohm, right? An ohm is the unit of measurement for resistance, right? It is the unit used to measure resistance, right? And it has such a symbol, right? Then we have ammeter. An ammeter is a component that is used in a circuit to measure for electric current in amperes, right? So it is an instrument for measuring electric current in amperes in a circuit. Then we have parallel circuit. A parallel circuit is an electrical circuit that has more than one pathway, right? We're talking of two or more pathways in that circuit, right? It has more than one pathway for the current to flow through. Then, now we begin with our main meal for today, a series circuit, right? So we've been talking about what? Electric cells. Electric cells say that they are our energy systems. They store potential energy later to be converted to kinetic electrical energy, right? We talked about resistance, the opposition of what? Of the flow of current in a circuit. Now it's time for us to distinguish between two circuits here, right? Parallel and series. But for today's lesson, our focus is on series circuits. So a series circuit now, it is an electric circuit that has only one pathway for the current to flow, right? As it says here, it is a circuit in which current flows along one pathway without branching. Are we together? So now, how does it flow now? The direction of this current comes from the negatively charged what? Negative charge of a battery, or negative terminal of a battery, into a positive terminal of a battery along the whole circuit, right? So let's look at the circuit, for example. So we have what? The long arm is our positive and the short arm is our negative, right? When looking at this circuit, it only has one pathway for the current to flow through, right? It doesn't have branches. So it is a series circuit, right? So the movement of current comes from what? The negative terminal of the battery, right? Flowing throughout the whole circuit, entering the bulb, right? The bulb becomes lit, right? Onto the second bulb where it's going to be lit again, right? Then the current flows back into the positive terminal of the cell altogether. It follows one pathway throughout the whole circuit, right? There are no branches where it branches to different directions, but it follows one pathway, and that's what a series circuit is. It is where current flows along one pathway, right? Looking at this example again, right? When this switch opens, right, it meaning on what? There's going to be no flow of electricity. But when it closes, what's going to happen? There's going to be some flow of electricity. But look at this. It also follows one pathway for the electricity to flow. What is this pathway we're talking about? We're talking about this conductor that we have here as a wire, right? It follows one pathway along the whole circuit, and therefore we call it what? A series circuit. Out together. So now, if one component in a series circuit is removed from the circuit, the rest of the circuit will not work, right? So as it says here, if one component in a series circuit is removed or disconnected, the circuit will be broken, right? The circuit will be broken and electricity can no longer flow through to the other side, right? What do we mean by that? For example, let's think of what? Our Christmas tree lights, right? So consider a set of Christmas tree lights connected in a series circuit. If one bulb breaks, right? Or if one bulb breaks, what is going to happen? The electricity cannot flow through to the next bulb, right? This is because they are connected in series, in a linear form, right? They are connected in such a way that they follow one pathway. Let's look at what we are talking about here. Here we have an example with what? 3 light bulbs in this circuit, right? We have our battery, right? Which is our source of energy. Then we have what now? We have current moving, right? Current flowing in the circuit. But look at this now. When you remove one light bulb from this circuit, what happens? The whole circuit goes off, right? When you remove one light bulb from the circuit, the whole circuit goes off. This is because now the electricity can no longer pass through to the other side, right? Now we see that the circuit is broken, or it is disconnected because of what? Removing one component from the series circuit, and the whole circuit now is not working. Right. So now, as we're talking about a series circuit, right? Let's look at when we're connecting cells in series, right? Meaning one cell after the other. So we connect cells in series by connecting the negative terminal of one cell to the positive terminal of the next cell, right? So let's look at this diagram, for example, right? Remember, this is a symbolic representation, right? So now here we have our positively charged what? terminal of this cell, right? And we have what? A negative, a negative terminal of one cell, right? So we have one cell complete here, right? And when we connect cells in series, we connect the negative terminal of one cell to the positive terminal of the following cell, right? So meaning this one also is going to be connected to this one in such a way, right? The positive terminal is connected to the negative terminal, right? So meaning your cells in a remote controller would be something like this, right? You'd be having what? A negative terminal this side, right? Positive terminal. Then another cell connected to this one with its negative terminal, right? And the positive terminal facing the other side, right? As we normally see on our some of the remote controllers for our televisions or any devices that we have at home, right? Every time when connecting cells in series, you connect the negative terminal of one cell to the positive terminal of the next cell, right? So now, when these cells now are connected in series, right? The negative terminal of one cell connected to the positive terminal of another cell. The total voltage of the battery is the sum of the individual cells. Now, what do we mean by that now, right? The total voltage of the battery is the sum of the individual cells, right? We mean what? The total potential energy that is stored in the battery is the sum of the individual cells of that battery. Are we together? So the more cells you connect, the higher the voltage of the battery. Are we together? Let's look at this example again, right? How many cells do we have here? We have cell 1, cell 2, and cell 3. We have 3 cells in total, right? And now we're looking at what? The voltage of the total battery, right? The voltage of the battery. And I'm saying to you now, the total voltage of the battery is the sum of the individual cells, right? So how can we identify voltage in a cell, right? We look at the markings here, right? The markings here. So each cell here is of 1.5 volts, right? So if we're looking for the total voltage of this battery now, it means we're going to do what? We're going to add all these cells or all these volts of these cells together to get what? The total voltage, right? So we're going to do what? 1,5 plus 1,5 plus 1,5 to give us what? To give us 4,5 volts, right? So the total voltage of this battery here is 4,5 volts, right? This is the amount of potential energy that is stored in this battery and is going to be transferred where? Into the circuit. Are we together? And take note that this is also a series circuit. It follows one pathway for the electricity to flow, right? It follows one pathway, and if you remove one component from this circuit, it means what? The whole circuit will go off. Right. Now let's quickly look at activity 1 to test our knowledge so far, right? So number 1 says, what do we know about the current strength at any point in a series circuit, right? Then number 2, what happens to the current strength when more resistors are added into a series circuit, right? So now I'm going to give you 3 minutes to copy and complete this activity. Then after that, we shall mark together. Welcome back, grade 9s. We are going to look at the solutions together now, right? So number 1 says, what do we know about the current strength at any point in a series circuit, right? So when current is measured at any point in a series circuit, it stays the same, right? It will be the same at any point in a series circuit. Then number 2, what happens to the current strength when more resistors are added in a series circuit, right? The current strength decreases as more resistors are added, right? So now I'm going to give you a quick minute to copy down these corrections. Then after that, we shall continue with our lesson. Welcome back again, grade 9s. Don't forget to interact with us on our WhatsApp number. Our WhatsApp number is 079 578 right? We are still waiting for those questions, comments, or answers regarding this lesson, right? So now, connecting resistors in series. Now, what happens when you connect resistors in series, right? In a series circuit. So resistors can be connected in series in a circuit, meaning one after the other, right? They can be connected in series. So we're going to look at light bulbs as an example of resistors, right? Because a light bulb is a type of resistor as well, right? So when we connect resistors in series, this is what happens, right? They follow one another, right? One after the other, following the pathway of the circuit. Are we together? So now, the unit of measurement, just a reminder, the unit of measurement for resistance is ohms, right? So that we're not confused when we continue with this one. So now, the total voltage across the battery is equal to the sum of the voltages across each resistor in the circuit, right? So meaning what? The total voltage of the battery is shared amongst what? The resistors in the series circuit. Are we together? The total voltage across the battery is equal to the sum of voltages of each resistor in the circuit, right? Let's look at the diagram below, right? So this diagram here, we have what? A series circuit, right? That has some voltmeters connected in parallel to the resistors to measure for what? For potential difference, right? So now what we say here is that the total voltage of the battery, where is the battery here? Here, right? The total voltage of the battery is equals to the sum of what? Of the voltages across each resistor in this circuit, right? So how many resistors we have here? We have resistor 1, resistor 2, and resistor 3. So meaning resistor 1, 2, and 3, when they are combined, they're going to give us what? The total voltage of this battery. Are we together? Meaning the total voltage of this battery is shared amongst resistor 1, resistor 2, and resistor 3, right? So total voltage in this case is equals to V1 plus V2 plus V3. Are we together? So let's look at more examples of that, right? Let's calculate for resistance in a series circuit, right? So as we said that in a series circuit, right, the total resistance now in a series circuit is the sum of all the resistors connected in the circuit, right? The total resistance in a series circuit is the sum of all the resistors, what? Connected in the circuit. So how many resistors do we have here? We have 1, 2, and 3, right? And their resistances are different, right? Resistor 1 has 2 ohms, resistor 2, 3 ohms, and resistor 3, 4 ohms, right? But we're looking for the total resistance now. And how did I say we find the total resistance? We add all what? We add all the resistors together, right? So we're going to do what? 2 ohms plus 3 ohms plus 4 ohms, right? They will give us what? 9 ohms in total, right? This is the total resistance, right, in this circuit, right? The total resistance also is shared amongst what? The resistors in the circuit, in a series circuit. So now, as we said that also, the total voltage of the battery is shared amongst what? The resistors were in the circuit. Are we together? So meaning what? This battery here is of 6 volts. So meaning what? The voltages are the same when it comes to these two resistors here, right? This one has 3 volts and this one has 3 volts, right? It is equal to the sum of each what? Resistors connected in the circuit. So these 3 volts plus 3 volts, they make up what? 6 volts, which is our total voltage in this circuit. Right. So as we said that a resistor now, a high resistance will have a high voltage across it, right? Why do we say that? Remember now, when talking of resistance, we're talking of what? The electrons flowing in a circuit and bumping into the atoms of a resistor, trying to resist the flow of current, using up that energy and transferring that energy into what? A useful transfer. Are we together? So a resistor that has a high resistance will have a higher voltage across it, right? So meaning if it requires to use more energy for it to transfer the energy, what is going to happen? It's going to use more voltage. Are we together? So a resistor now that has a lower resistance will also have a lower voltage across it, right? But now remember, when we measure current anywhere in the series circuit, it will be the same whether it's measured at point B or point A. The current is the same throughout in a series circuit, right? So I was saying here, when we measure current, right? Current is measured in amperes, right? Whether we measure current at this point, we measure it at this point, or we measure it at this point, it is the same, right? So also I said that now the resistor that has more resistance will have more voltage passing through it, right? For instance, look at the 3 resistors here. We have resistor 1, resistor 2, and resistor 3, right? Which one has the highest resistance? Resistor 3 has the highest resistance, right? So meaning what? More voltage will be passing through what? Through resistor 3 because it is of 4 ohms, right? Also now more voltage will be passing on resistor 2 because of its 3 ohms of resistance, right? Then less what? Voltage will be passing on resistor 1 because of its resistance is 2 ohms, right? So now the higher the resistance, the more the voltage will be passing through that resistor. The lower the resistance, the lesser the voltage that will be passing through that resistor, right? So now, as we said that when measuring current in an electric circuit, right, at whatever point you measure it, it will be the same throughout the whole circuit, right? So now, the current in the circuit decreases with each resistor that is added. So in a series circuit, right, probably have one bulb. It will shine bright, right? But the minute you add another light bulb next to the other one, the brightness will start to become dim, right? Because of what? The current decreases which with each and every resistor that is added in series in a series circuit. We can also measure current with a component that is called an ammeter, right? So we have an ammeter alongside here, which is an example of a, so we have a picture here, which is an example of an ammeter, right? An instrument that is used to measure for current. Current that is measured in amperes, right? So it will give you an answer with the units of amperes, right? So the unit of measure, as I've said, it is amperes, having the symbol A. So now, an ammeter is always connected in series because it has a very low resistance, right? So here we see what an ammeter connected in series, right? And remember, whether the ammeter is placed here or anywhere in our series circuit, the current is the same, right? The current is the same throughout. So now, let's test ourselves now with activity 2 and see how far we understand, right? So number 1 says, what do you think will happen to the brightness of a light bulb if another light bulb is added in series? Number 2 says, what do we know about the total voltage across the battery of a circuit with resistors connected in series? So I'm going to give you a quick 3 minutes to complete this activity. Then afterwards, we're going to mark together. Welcome back, grade 9s. Let's look at the solutions together. What do you think will happen to the brightness of a light bulb if another light bulb is added in series, right? What will happen? The brightness of the light bulb will decrease, right? It will become dim. So what do we know about the total voltage across the battery of a circuit with resistors connected in series, right? The total voltage across the battery of a circuit with resistors connected in series is equal to the sum of the voltages across each resistor. Are we together? So these are our answers for activity 2. Let's take another quick minute to copy down the corrections. Then after that, we shall move on to another activity. Welcome back, grade 9s. Now let's move on to activity 3, right? So this one I'm going to read through for you thoroughly, right? So that you understand what is needed to be done, right? So now it says the circuit diagram below shows a battery, 3 resistors in series, which is resistor 1, 2, and 3, and 2 ammeters, which are ammeter 1 and 2, right? So there is a voltmeter connected across the battery as well as across each of the resistors. The reading on ammeter 1 is 2 amperes. The potential difference in resistor 1 and resistor 3 is 1 volts each, right? So here you have the diagram to refer from. Now let's read through the questions, right? What will be the reading on ammeter 2? And give a reason for your answer. Number 3, the reading on the voltmeter across the battery is 4 volts. Now calculate the reading on the voltmeter across resistor 2, right? So now because we have calculations also here, I'm going to give you 5 minutes to complete this activity. Then after that, we are going to mark together. And please do not forget to send in those answers on our WhatsApp number on the screen, right? Let's meet again after 5 minutes. Welcome back again, grade nines. Now let's read through the statement before we go to the answers again, so that we have the correct data, right? So the circuit diagram below shows a battery, 3 resistors in series, and 2 ammeters. There is a voltmeter connected across the battery as well as across each of the resistors. The reading on ammeter 1 is 2 amperes. The potential difference, which is what? Our voltage, right? In resistor 1 and 3 is 1 volts each. So number 1 says, what will be the reading on ammeter 2? And give a reason for your answer, right? Number 2, the reading on the voltmeter across the battery is 4 volts. Calculate the reading on the voltmeter across resistor 2, right? So these are our solutions. Number 1, it is 2 amperes, right? Why am I saying so? Because of what? The current is the same at any point in a series circuit. Then number 2, calculating the resistance of what? The voltage of resistor 2, right? So now it is what? As we said that resistor 1 and 3, they have 1 volt each, right? So here we have the formula. Total voltage is V1 plus V2 plus V3, right? So they give us what? Total voltage. So we have what? Over voltage for resistor 1 and voltage for resistor 3, right? We're looking for V2, right? So now 1 plus V2 plus 1, right? 1 plus 1, they give us 2, right? So this V2 plus 2, right, they give us 4, which is the total voltage, right? Then the 4 minus 2, they will give us what? 2 volts, right? So that is the answer for question number 2. So if you need a minute quickly to copy down these corrections, I'm going to give you now. Then after that, we shall give you another chance to ask any question on our WhatsApp line. And if not, we are going to wrap up our lesson, right? So take a minute quickly, copy down these corrections. Then after that, we shall continue. Welcome back again, grade nines. Now, let me give you a chance to flood in our WhatsApp line with your questions, comments, or anything regarding this lesson, right? We are more than willing to help, right? A reminder here, our WhatsApp number is 079 and I'm going to give you 2 minutes tops to do so. Then after that, we shall wrap up our lesson. Welcome back, grade 9s. Silence means consent, right? So now, there are no WhatsApp questions, comments, or anything regarding this lesson, right? So it's time to wrap up our lesson. Now let's summarize what we have learned for today. Today we're talking about series circuits, right? And we said that a series circuit provides only one pathway for the current to flow, right? As it provides one pathway for the current to flow, it means what? When you remove one component from the circuit, the whole circuit is broken and it's not going to work, right? Because the electricity cannot pass through to the other side. So also resistors can be connected in series in a circuit, right? So a light bulb is a type of resistor, for example, and the unit of measurement for resistance, just a reminder, is ohms, right? And we said that now the total voltage across the battery in a series circuit is equals to the sum of voltages across each resistor in the circuit. Are we together? Also, we said that resistors connected in series are potential difference dividers, right? They are voltage dividers, right? They share the voltage amongst them, right? They share the total voltage of the battery amongst them. Hence, the total voltage of the battery is equal to the sum of individual resistors in a circuit. So the current flowing through the circuit is the same throughout. So when taking an ammeter and measuring for current at any point in a series circuit, it will be the same throughout. And also when additional resistors are added in series, the current strength will decrease while the total resistance will be increased, right? That's one of the things we talked about in this lesson, right? So this is an example of a series circuit, right? Looking at this, it has what? One pathway for the current to flow, right? And we said that the direction of the current, it moves from negative terminal of the cell or battery along the whole circuit and back to the positive terminal of the cell or battery, right? And when looking at the power of this current here, it is 1.20 amperes in this example, right? So meaning also if you measure this current here, 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 or here, it will be the same, right? It will still give you 1.20 amperes, right? So that's all for today's lesson. In the next lesson now, we'll be talking about parallel circuits, right? Parallel circuits which are different now from series circuits. If you look at this example for already, it has more than one pathway for electricity to pass through, right? That's what we'll be dwelling more on the next lesson. So please, you know what to do. Go home, read more about this so that when we come back here, it is an easy learning and teaching process, right? So from me to you now, thank you and goodbye.